welcome to Digital Electronics lecture series. This is lecture number 14, and today we'll be learning about how to convert any equation into a canonical SOP or canonical POS. Canonical means standard form. But before studying that, we'll prove one Boolean expression. So suppose we want to prove this. We have to prove this, and A or C. So we have to prove this. A or B and C equal to A or B and A or C. We have to prove this. So let us take the left hand side. So left hand side is A or B and C. Now this A can be written as A and 1 because A and 1 is A. Then this 1 I can write it as 1 or B. So 1 is equal to 1 or B. Now I expand this. So when I expand this, what we get is A and 1 or A and B or B and C. Next what I do is this one, it can be written as 1 or C. So we again expand this expression. So if after expanding, what we get is we expand this, so we get A and 1, or this is what we get. Now this A and 1, let me write it here. So A is equal to A and 1, which is also equal to A and A. So these three are equal. So I can, instead of this, what I write is A and A, and remaining all the things remain same. This is what I write, B and C. Now I take common. So I take common is I can take A common. So what I'm left with A or C, and here I can take B common. So I get A or C. So I just write the final expression here. What I get is this is A or B or A or C and A or C. So this is what we get, which is equal to the right hand side. Hence it is proved. So this is what we have proved this. So A or B and C is equal to A or B and A or C. So you must remember this because we will be using this for standard SOP and POS expressions. Okay. Now next we do the problem, convert the following equation to canonical SOP, or canonical means standard SOP equation. So let us see the first one. We will see an example. The first one. So we are given f of a, b, c. So many times we refer the function by writing this way. So we have this a, b and a, c bar. So we are given this equation. So this equation can also be written in this way, y equal to a, b or a, c bar. Whether we write in this way in a function form or in output form, it is one in the same thing. Okay, but why I am writing in function form, so that we must know this particular expression depends on how many variables. So from here it is clear that it depends on 3 variables. I will write it again. Sorry, I will just let me take any random this a bar c. Okay, this is the equation. Now how to get this equation is not a standard SOP. This is of course SOP, sum of product. SOP means sum of product. This is actually sum of product equation, but it is not a standard form because in this particular A and B is present, C is not there. So C should be either present in complemented or any other uncomplemented. Here A bar C, B is missing. So now we convert this particular expression to standard SOP. So how do we do this? So we have this is equal to A, B, we can write here 1. No, nothing is there, we can write 1. Same way here also we can write 1. Now what is missing in this? So here what missing is C is missing. So what we do, I will just show with an arrow mark, then we can continue. So instead of this 1, I write this 1 is equal to C or C bar. Okay, then I write this one because B is missing here, so I write this as B or B bar, because we know according to Boolean algebra A or A bar is 1. So 1 is A or A bar, same way 1 is equal to C or C bar and 1 equal to B or B bar. So we substitute this. So what we get is we get this is equal to this is A, B, and here C or C bar or A, C, and here B or B bar. Now we just expand it, simply expand. So we have this A, B, C or A, B, C bar, sorry, A, B, C bar or A bar, C, B or A bar, C, B bar. So we can just even arrange this sum A bar, C, B, C, and this is also, it will not change the expression but just for simplicity. So this is what we have, A, B, C or A, B, C bar or A bar, B, C or A bar, B bar, C. So here what we see is this expression is a standard form because every term contains ABC, whether in uncomplemented or complemented. So whenever we have a SOP equation, we can convert it by convert it into canonical form by this particular method. Okay. Now next problem is convert the following equation to canonical POS, that is product of sum. So canonical is also called as a standard POS equation. So we have equation f of ABC. So it is a three variable equation which is A or B bar and A or C. So in this equation C is missing and here B is missing. So how do we solve it? So first of all, we know this that A bar is 0, B bar is 0, C bar is 0. Now in this particular equation C is missing and here B is missing. So what we do now is we write this is equal to A or B bar, missing is C bar, so here we write is C 0. So this is same, A or B or 0, B bar or 0, so it won't change the equation. So this is, we write in this way. Same way here also, A or C or 0, so this is same as 1. Now here because C is missing, so we use this equation here, so we'll use this here. So what it becomes, this equation then becomes, this equation becomes, this is equal to A or B bar or C bar. So 0 is equal to C bar, and here this we use here, so it becomes A or C or B bar. Now we use a property of Boolean algebra that if we have A, let me not take A, we will take a PQR. So P or Q dot R, the QR, this is equal to P or Q and P or R. So this is equal to this. So same way here, instead of A plus A or B bar, we have, instead of P we have this, and this is this. So instead of Q we have C and R we have C bar. So how this, if we apply this particular rule, if it is applied individually to these two expressions, so what we have is A or B bar. Now C will come, or C. Then in the next one we have C bar. So this C and C bar, they are divided here. Then next we do the same thing here with B bar. So what we are left with, this is continuation. So here we have A or C or B, and here we have A or C or B bar. So this is what we have. So I can just rearrange the terms. So what I get is equal to A or B bar or C, the first term as it is, the second term is also as it is, the third term I just shuffle this B and C. So A or B or C, and the final term A or B bar or C. So this particular term is a standard POS because it contains all the variables A, B, C in each and every in this particular case. So this also contains ABC, this also contains ABC, this also contains ABC, this also. So this is standard form. Okay, so that's all for this session. Thanks for watching.